Hello and welcome. I apologize for this YouTube version, but I was having technical difficulties. So, this is my presentation. My name is Alex Munoz. The class is Stats 508. The original stats, as you can see here, was given to me by Kevin Cho. Kevin Cho is a second-year grad student, and he was looking at force at the hip moment and the knee moment, comparing front squats to back squats. Starting with my regression stats, the two variables that I was looking at or comparing is the IV is the height and the DV is the front squats in pounds. The height is listed on the left side of the chart I have. The lowest number I have was 1.6 in meters, which is the height, and the front squat in pounds varies a little bit more than that. The highest height was 1.91. So what I was trying to say is 1.6 to 191 is the difference in height. This is a descriptive statistics. The mean, median, mode is listed. The mean, median, mode have a somewhat of a similar number. They're pretty close together, which tells me it reflects normality, especially for height. There's also the skewness and kurtosis score, and the variance. This is the three main tables, which is the model summary, ANOVA, and coefficients table. From here, I concluded that height in M significantly predicted front squats with the formula of F, open parentheses, 1 degrees of freedom, comma 15, close parentheses, equals 10.18 with the significance of 0.06. So height in M in meters explains 40.4% of the variance with the R square score of 0.404. And for those two plot graphs, that we will be looking at that in the assumptions table, and the table on the right, that has already been explained. That is the same table, just the table alone with descriptive statistics. And this will also be addressed in the assumptions. Okay, so for the regression assumptions, so assumption, the first assumption, sample size, was not met because we did not reach at least 40 individuals. With our number of 17, there should have been a 20-to-1 ratio with two variables. So that was not met. Assumption 2, absence of outliers, was not met as well, because in the histogram you see in the bottom left corner, it seems like there is some outliers. Assumption 3, the normality assumption, that was met. That looks like a pretty straight line, with residuals not being too far off from the straight line. The assumption 4, that was not met because there is a lack of homogeneity. The residuals look asymmetrical and scattered. And then here is the histogram again. And then we are following it with ANOVAs. ANOVA. In the ANOVA, we were comparing the IV, which was 3 different age groups. Age 1, ages 20 and 21. Age 2 is 22 and 23 years of age. And age 3 is 24 through 27 years of age. Our null hypothesis was there will be no differences in front squats by age groups. And the hypothesis was that front squat RM will differ by age group. This basically summarizes it already. Height significantly predicted front squats in pounds with a formula of parentheses 1 degrees of freedom, comma 15 equals 10.18 with a significance of 0.01. And height explained 40.4% of the variance, which means almost 60% is not explained. Okay, and the conclusion for all of this is that front squat did not differed significantly by age group based on the p-value. So the age groups basically meant nothing. And the effect size was an answer of 0.176 based on dividing 13039.804 divided by 773,926.470. And on to the assumptions. The assumptions, first assumption was not met. There was not normal distribution. Assumption 2, homogeneity of variance for height, it was met. It was normal. And from the front squat was not met. So this assumption was not met. Assumption 3, random selection, we can't say for certain how random it was. So we're going to have to not meet this assumption. This is assumption number 4, interval ratio. It was ratio because the dependent variable could potentially be 0. It can't be below 0. So this assumption was met. And overall thoughts of this, I think it was